Great. We are at module number 9. There is only one more module left for lecture. And that is on purpose because you need all the time you can get to work on the small and large cases. So after this lecture and next week's, there is no need to meet at this time anymore. It will just be working on the cases. And as usual, you can always ping me on Discord for help, for any questions. But after these last 2 lectures, there's no real need to meet. So let's run through this, and then we'll talk about the cases, and we'll be off working. So this lecture is all about the mobile network, the mobile devices that we use. A cellular network is a group of cells or geographic area within a network. A cell site is a tower located in a cell. A mobile switching center switches data packets from one network path to another on a cell network. If the user calling is managed by another carrier, the call will be routed to the mobile switching center off to the public switch telephone network, an aggregate of all circuit switch telephone global network. These cell towers that we see all the time are about 200 feet high, with the transmitting panel in the middle, and everything else are the receiving panels. These towers are controlled by the base station controller, who handles frequencies and hands-offs as mobile equipment move from one cell to the next. A soft handoff is when a cell communication is conditionally handed off, where the signal strength on the base station will be adjudicated from one base to another, and the mobile equipment is simultaneously communicating with multiple. A hard handoff means that communication is only handled by one base transceiver station at a time. Understanding how cell networks are structured is good to understand the type of evidence that can be retrieved from a carrier's network without access to the suspect's device. Law enforcement can request cell site records from a carrier, specifying the format they wish the evidence to be in. Law enforcement can contact the network carrier and explain the user information they seek, as well as ask the customer not be notified. Law enforcement can request suspects' records be preserved for 90 days, pending their acquisition of a search warrant. Court orders can extend this for additional 90 days. Law enforcement can obtain the subscriber information, everything from, the name, the address, the social security number, and so on, along with call detail records, the same records that are used for billing, like phone numbers called, the duration, the times, the cell sites used, and any PIN unblocking key codes are used to corroborate evidence from the carrier and the user's device. The actual term for your cell phone or anything that connects to the mobile network is a mobile station. The mobile station is comprised of the handset and a subscriber identity module, or SIM. An International Mobile Equipment Identity, IMEI number, uniquely identifies the handset, like a MAC address. The initial 6 to 8 digits are the type allocation code that identifies the type of wireless device. There is a link in the lecture notes for a site that can show you details about specific devices. The Universal Integrated Circuit Card, UICC, is a smart card that identifies the subscriber on a GSM or UTMS network. For all GSM networks, that is the SIM card. For UTMS, it's the universal SIM card. There is the Mobile Equipment Identifier, MEID, an internationally unique number for all CDMA devices. This number has the manufacturer code and a serial code for the device. Many CDMA devices have a subsidy lock, confining the subscriber to a certain cell network so that it can be sold for free or at a subsidized price. This means a phone's file system cannot be acquired with an active subsidy. For example, an iPhone could be $99, but you're locked to a particular carrier in contract, whereas a phone paid in full price can be unlocked. This is good to know because the phone may have been used internationally with a SIM card purchased abroad. This type of lock, the subsidy lock, is not found in Europe. All US phones have an FCC ID, indicating the device is authorized to operate on radio frequencies within the FCC's control. Manuals and information can be obtained using that ID at a site I linked in the lecture notes. The SIM card. The International Mobile Subscriber Identity, IMSI, is another internationally unique number on a SIM, like a MAC address for the SIM. The mobile country code is the first 3 digits, with the preceding 2 to 3 digits as the mobile network code. A mobile subscriber identity number is created by the carrier and identifies the user on the network. Mobile subscriber ISDN is the phone number for the subscriber. SIM cards also have an integrated circuit card ID, a 19 to 20 digit serial number located on the card to help identify its origins. The mobile switching center is where user information passes to the home location register. That is the database of subscribers and has the personally identifiable information along with other information. It has the visitor location register. It's a database for all roaming subscribers. Users will be found in one home location register, but will be found in multiple visitor location registers. The mobile switching center also has the equipment identity register, which keeps track of IMEI numbers and decides which one is valid, suspect, or stolen. And also has the authentication center, the database that has the IMSIs, has the authentication and encryption algorithms that issue encryption keys for all the wireless communications. There are 2 main types of networks that are done by 2 different groups. You have the mobile network operators who own and operate their network, and the mobile virtual network operators who don't own their own network but operate off of the mobile network operators. From there, we have the evolution of cell phone communications from the days of 2G all the way to current 5G. 2G used to use the time division multiple access to allow devices to communicate on the same frequency by splitting signals into time slots or time bursts. The global system for mobile communications is GSM. It's an international standard created in Europe. The most pervasive standard of GSM is 4G LTE at the time of this writing. Now it's 5G. The code division multiple access, or CDMA, is a sped spectrum communication methodology used by Verizon and Sprint. Kind of similar to the whole DVD plus R minus R thing. All SIM cards have an interface to communicate with the device, and it's usually that plate. Within a SIM card, you have a hierarchy file system. The OS, user authentication, and encryption algorithms are all in ROM. The three primary areas of the SIM card's file system are the master file, the dedicated files, and elementary files. EF, the elementary file, is where subscriber information is stored. A couple of notables are the ADN, that is the abbreviated dialing number. It has the list of contact names and all numbers stored. SMS has a list of all your text messages. LOCI is the area where the user last powered down the phone. So it stores the geographic area when the phone was last powered down, along with the temporary MSI and the visitor log. So there is on the phone, on the SIM card specifically, a place where you can find where the phone was last turned off. There is the LND, that's the last number dialed. And the last one, FPLMN, is the Forbidden Public LAN Mobile Network. Any cell networks the device attempted to connect, but was not authorized to. This is all useful information to know where a suspect was located. Since SIM cards are protected, investigators usually have 3 attempts to get the PIN correct before it is locked. After that, the unlock key will be necessary from the carrier in order to unlock the phone or unlock the SIM card. SIM cards can be cloned, and most software tools are able to clone SIMs. SIMs can help an investigator determine whether a text message was read, deleted, unread, sent, unsent, based on status flags. MMS messages can be carved using forensic tools. Rich communication services such as WhatsApp and Signal, they still maintain the same legal intercept standards as SMS, even if they're using encryption and other things. So it is still possible, even with a app like Signal, to see if a message was deleted, if a message was read, if a message was unread, sent, or unsent. We may not know what the contents of it was, but we can see this. A quick look into Android. Based on the Linux 2.6 kernel and moved on from there, bought by Google in 2005, can be found everywhere. Some of the common partitions that you will find on an Android phone are the boot partition, which contains the boot code for the device. It includes the kernel and RAM disk, which is associated with an unmodified, there's MK boot image, a Linux command line tool for developers. It allows the developer to create a new boot image. There's the /system that contains the Android framework, the recovery, stores recovery image, the cache that stores temporary data, the MISC, which holds recovery partition, the user data that contains the user installed apps and data. It's the most important partition from a forensics perspective because it contains all the user activity associated with any mobile applications. Metadata has information when the device is encrypted. There's also the Dalvik cache, which is a location where .dex files exist. So all files that were ran. There's an applications where all the APK files are sitting, the Android application package files. Within all the applications exist a data folder that usually has a SQLite database that can yield quite the amount of information from the application and the user's usage. Mobile forensics is not easy. Gaining access to evidence on a suspect's computer is challenging in and of itself. This means that experimental techniques may be the only course of action for an investigator. Since forensics is a science, whatever action was taken must be documented and repeatable. Circumventing encryption often means destroying the device beyond repair to access the data. And even then, it may not be successful, and the prosecutor should be aware of this. Mobile device forensics requires the entire system and may not be able to separate the volume during examination. Write blockers are typically not an option, and creating two copies may not yield the same hashes. Outside of logical and physical ways to extract evidence from, let's say, an Android phone, there's also JTAG, chip-off, and ISP. The Joint Test Action Group, or JTAG, is an IEEE standard for testing, maintenance, and support of assembled circuit boards, and is an increasingly important way to bypass security and encryption on a smartphone. This picture here shows a RIF box used to acquire data from a circuit board on a cell phone. A full dump of the NAND memory can be obtained by extracting the contents of the storage chips. These connectors are soldered onto JTAG points on the board, and then voltage is applied using a cell battery. This would actually be the second step. The first step would be using a tool like Cellular Network, where you don't have to open up and start poking around the device. If Cellular Network doesn't work and JTAG doesn't work, then the last resort is chip-off. This is an expensive process which requires specialized skills and is not always successful. The microchips are removed from the board and added into adapters like these in order to be read. There's also the in-system programming, is the practice of connecting a storage chip in order to access the files that are stored. We're not actually removing the chip, we're just connecting to the pins. It's less invasive. Now, if you're lucky enough that the suspect or the device has the, for example, if it's Android, the Android debug bridge, ADB, turned on through USB debugging, then you don't have to do any of these things. You just connect that way and you're good. As with digital forensics on regular machines, all tools should be validated before you use them. There are steps that should be taken for preparation and containment of a mobile device. There is a Department of Justice guidelines to help out with that. And they're pretty much the same: securing and evaluating the scene, documenting the scene, collect the evidence, package, transport, and storage using chain of custody. With specificity to mobile devices, proper containment means removing the device from the network with the use of Faraday boxes like these. Remember that the issue with mobile device is they require frequent charging because the device will boost its signal in an attempt to connect to a cellular network, along with other apps trying to communicate as well. Once the phone shuts down, there is risk of encountering a user's PIN or password to unlock. And you also don't want to keep a cable connected to a mobile device that's in one of these boxes because the cell phone will use that as an antenna to get out to the world. Signal jammers are not an option. They're actually illegal, even for law enforcement to use, because the FCC has stated, should an emergency situation arise, a person in distress may not be able to contact emergency services. Cell phone carriers should be contacted to ensure the phone is removed from the network. This would prevent a criminal to report a lost cell phone or have it erased before law enforcement seizes it. So it allows, by disconnecting it from the cell phone carrier, it allows law enforcement to preserve that device without giving that chance for the suspect to do anything to it. As I mentioned, there are a couple of tools that exist to law enforcement, like a gray key that is used for iOS devices to bypass pins. There's BitPim, there's Mobile Forensic, E3, and of course, Celebrite. When all else fails and an investigator does have access to the device, you could always take pictures as you thumb through the contents of a phone. Any questions? Cool. So, as I mentioned at the start, Module 9 only has a review. Module 10 only has a review. There's no other extra work to do because I want your full energy and time to be used on the 6 big cases. You can absolutely think of these as your final exam. It does not matter what order you do them in. You could start by doing these big ones. You could start by doing the little ones. You could start in the middle, start at the top. I don't care. It doesn't matter to me. You have these remaining 8 weeks until May 18th to submit your report for all 6 cases. You are absolutely welcomed, encouraged to work together with other students in the class. I do not expect anybody to be able to solve these on their own in 8 weeks. If you need cloud credit, let me know. But what we will be doing going forward is just working on the cases because they're gonna take that much time to work through. Remember the template that I talked about a couple of weeks ago? Use that template. Remember that you're being an objective investigator. You're not making a judgment on who did it or who didn't do it. You're just providing the evidence and saying objectively what you find. Nitroba is, I believe it's the smallest of all the cases because it's only a PCAP file. Narcos and Lone Wolf, these three really are pretty big in that the files you need to process through will take a while. So hopefully what you could do or have already been doing is processing these image files and getting them ready so that in autopsy you're good to go. There is a autopsy multi-tool that came out a while ago where you could collaborate on the same system. So if you are working in a team, you could have one server be the centralized server that processes all the information and everybody else looks through. So you save on time. I need to make a change to this. Instead of using WireGuard, I suggest using Tailscale. I think this will be a better use than WireGuard. It's much easier to use. It has less steps where things can go wrong by using Tailscale. So I'll update that. But you have Tailscale to connect multiple machines together, and you could use this multi-tool so that one server has all the data, one server does all the processing, and everybody else in the team, everybody in the team can look in their own autopsy instance to the same data in one place. Does that make sense? Excellent. Then off we go to working